Okay, so we are looking at solving a physics problem, finding the electric potential. And here's our setup. I'll get rid of all of this and get rid of this little bit here. Okay, so we have charge Q1, negative 20 e minus 5, charge Q2, plus 10 times 10 to the negative fifth. 2 meters away is charge Q4, I call him, right here. And this guy is Q3, 2 meters away, 2 meters away. This distance is 2 radical 2, like up here, which is the same as 2.83 meters. Okay, so if I want to know the total potential energy stored in the system, that's going to be equal to the total amount of work I do to put these charges there, because the potential energy comes from me pushing on them to get them in place. And so I'm going to, one at a time, put these things in place here. So I'm going to start with Q1, and I'm going to put him here. And it doesn't cost me any energy because there's no other charges around it. It's out in the middle of outer space. Now, when I put charge 2 in place, that's going to require me to calculate the electric potential there. U12 is going to be K Q1 Q2 over R, which is going to be 9 times 10 to the ninth times negative 20 e minus 5. Oops, I should do that lower, because I am going to run out of space. Oh, that should be good. Okay. Times 10e minus 5, that's the positive charge, all over the distance between them, 2.83. And when I turn the crank there, I get, let me do this in my head because I'm super smart. Boop, boop, boop. I get potential energy 1, 2 to be, please check my math, 63.6 joules. Okay, that's to bring charge 2 here. Now, I am going to do for in no particular order, because energy is a scalar. I don't think it matters what order you do. I'm going to bring charge 3 in now. Well, charge 3 feels charge 1 and it feels charge 2. So I know from symmetry, because charge 3 is the same as charge 1 and everything is equidistant, the energy for 1, 3 is going to be the same as the energy for 1, 2. Right? It's the same distance. This is the same 10 times 10 to the negative fifth coulombs. This is minus 20 times 10 to the negative fifth coulombs. Same. U13 is going to be the same as U12. Okay, so now let's look at this pair. So that's going to be the potential energy from charges 2 and 3. So that's going to be K, K Q2 Q3 over R. So that'll be 9 times 10 to the ninth times 10e minus 5 times another 10e minus 5 over R, which is, since this one's 2 and that one's 2, R is 4. And when I go to calculate that one, U23 is going to be, oops, let me write that a little better. There we go. U23 is going to be boop, 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 4.5 joules. Okay, just by crunching all those numbers. So now, let me get rid of these. I am going to bring, oops. So I did this pair, right? I did that pair and I did that pair. Those are all the possible combinations for charge 3. So now I'm going to bring in, let me get rid of this. And that, I love that tool. So now I'm going to bring in charge 4. And charge 4 is going to feel this electric potential energy. So it's going to get U24, which is going to be K Q2 Q4 over R, which is going to be the same as this one because Q3 and 4 are the same charge and at the same distance. But it'll be 9 times 10 to the 9th times Q2, which is 10 times 10 to the negative 5th, times Q4, which is 2 times 10 to the negative 5th, all over 2, because that's the distance here, is 2 meters. And when I turn the crank on that, U24 is going to be, beep, boop, beep, it's going to be 9 joules. And likewise, Q34 is going to be 9 joules. Oops. So I did this one and I did this one. Now I have to do this potential energy from that pair. And so that will be potential energy 1, 4. So that'll be K Q1 Q4 over R, which is going to be 9 times 10 to the 9th times Q1, which is negative 20 E minus 5, Q2, which is, or Q4, which is 2 times 10 to the negative 5th, all over 2. And that one comes out to be, I did it again. There we go. Negative 18. Okay, so we did all the possible combinations of charges. So now the total potential energy of this thing is going to be the sum of all of these. Negative 63.6 plus a negative 63.6. I got that one and that one. Plus 4.5, that's these two. Plus a 9, that's these two. Plus another 9, that's these two. Minus an 18, that's those two. And let's see, these will cancel, right? 9 and 9 is 18. So if I do the math now, 63.6 times 2, because I got 2 of them, I end up with negative 122.7 joules. I'm betting, Hannah, that is the answer to that homework problem. So please test it and let me know. But I'm pretty sure that's the way it works. Okay? So I hope that works, and we'll find out when we meet next. Bye.